Hello and welcome. Today we are going to do a little bit lengthier exercise, and the topic is deploying Docker app on EC2 Instance. There are certain concepts which are needed to be known before we start deploying the Docker application. So let's try to understand the basic concepts about the Docker. What is Docker? Docker is a platform for a developer to develop, ship, and run applications faster almost everywhere in any environment. Docker image is like a blueprint basis for creating container. That means there is a Docker file which is used to make any of the application or software into the Dockerized image, and that image is just a blueprint which will be used to create the container. So next concept is the Docker container. Docker container contains the application and OS operating system, which can be Linux operating system or Windows operating system, which makes it environment inside the Docker environment to make or give the sufficient environment so that Docker container can run the application very uniformly, and it is possible to run on any type of platforms. Next concept is Docker registry. Docker registry is a central distribution point for deploying Docker containers. So just like Git or GitHub, GitHub holds the source codes. Your Docker registries are going to hold the Docker images, from where you can distribute the Docker images to the different deployment environments. Docker registries are held by DockerHub. So DockerHub provides the facility just like a GitHub. It provides the facility where you can create a public Docker registry or a private Docker registry. Public Docker registries are free, while the Docker registry private is created per organization, and that is private, so it is licensed. Next concept is Docker engine. Docker engine gives the environment or runtime for the Docker, which will help to do the various tasks, which can be building the Docker images, running the Docker container, managing the Docker container lifecycle, managing the networks, etc. So these are all basic concepts which will help us to deal with the application deployment when we are doing next. So let's go ahead and start doing the things. Yeah, so before you start, you need one account to be created in order to complete this lab with the DockerHub. DockerHub is a public URL where you can create your free account, and the same account will be logging in with to put our image into the repository over this Docker registry. So yep, so that's something we are going to achieve now. Let's get started. So first of all, what we need is EC2 instance. In the AWS console, we are going to create a EC2 instance. I have already one custom VPC which is existing, and my Docker application is going to use RDS database. RDS database is currently deployed with the MySQL 5.7 version. So I have a database already existing, so I'm going to use the same database for my application, but feel free to use any of the application which does not have any database, which will be more easier to complete the lab. So I'm in the North Virginia region and going to launch EC2 instance. So I've just clicked the EC2 instance and waiting for the dashboard to load. I'm not logged in, so let me confirm my login so that I can proceed further. And with this, I'll be redirected to the EC2 dashboard. And I need one Amazon Linux image for EC2 instance. So I'll take a first one, which is having the Amazon Machine Image for Amazon Linux. So this suits my requirement. I'll go with the free tier eligibility. And here I'm going to choose my VPC, which I have created my custom VPC in the same region, North Virginia, and it is listing over here. So that is showing up. And subnet, I'm going to change it to the app, the one that I have created with the internet gateway, and which allows to get the traffic out and in. So inbound rules and route tables are set with the proper internet connectivity. So and third thing I need is to have the public IP created for this instance that I'm launching. So I'll turn on this flag. Once I'm done with the first screen, here second screen, the follow-up screen should be with the storage allocation, which I am good with the default size of 8 GB for Amazon Linux. Next is to put the tags. So I'm going to give a tag as a name, key, and value as app server. So this is going to be my app server. And the security group that I'm going to require for my application is TCP. Actually, the TCP for custom TCP up. So this one with the port number 5000. This is the port number that I'm using, but you can use any port that suits your requirement. So the second one is to use the 6 for anywhere. So I'm going to just make sure that my IPv6 is smoothly able to connect to the application that I deployed. So I did for both of the IP versioning. Next is to just review whatever we have done so far. So we have added a custom TCP rule for making our application be accessible from outside the Docker application that we are going to deploy. It's going to be a web application, which will be Dockerizing it and running on the port 5000. Rest of the other details are like the image that we were looking for is the Amazon Linux. So we are good with this. And the instance type is T2 Micro. Database is something we'll connect from here to there. So we do not require any kind of security group for that, because this is going to be internal communication. Both of the servers are going to be in the same VPC, so there's no specific rules required. They're controlled through the route table currently, so that is already configured. I'm going to use the key my app key pair, and which is the existing key, but feel free to download the new key pair if you do not have. And this key pair is required when while I will be connecting to this newly launched EC2 instance for SSH connectivity, so that I can do execute all of my commands and make my system bootstrapped completely so that it is usable. So for that, I need to have SSH connectivity. It is going to take a while for making it up. So let's meanwhile, yeah, so this is running now, and we have public IP over here. So let's check it and open a cmd command prompt, and my here is over here, so I can do the SSH to this particular box that we have launched currently. So my there at the IP address should be able to connect. It says there's authenticity issue and should are here, and let's see, there's nothing as of now. So what we have to do, first thing we have to do is to install the Docker engine, which is required because the Docker engines are going to give us the environment for Dockerizing and creating an image and running the container and maintaining the lifecycle. Also at the end, we'll push the same image into the DockerHub registry. So for that, we need Docker registry. Let me quickly check the commands from here to install the Docker. I have the installation command now. This will install the Docker. Going to be very quick. Well, I'll take much. But if we want to add the user, because without that we'll not be able to do it. So let's see that this works, and then we also need to add this user to the Docker, because without that we'll not be able to execute our command. So this is mandatory. And then we should now disconnect and reconnect, because we have just added the user to the group Docker. So we should disconnect and reconnect so that EC2 user should have that permissions to deal with these commands. So now what I'm going to do is I'm going to copy the applications that I have. So I'm going to copy my application using the curl command. To EC2 directory. So I'm going to first create the apps folder or app. The command is going to pull the jar file, which is my application jar file, from the S3 bucket of my account. So this is my account's S3 bucket where an application jar, which is Java-based application, which internally runs on embedded Tomcat. So this is the one that I would like to download and make it Dockerized. So it's going to be quick, yep. And then we have the jar file. What I'm going to do is I'm going to rename it to my jar. The name is not lengthy now. Also going to make sure I give a proper execution. This everything, the rights that I'm going to give to this file. So full rights from the user's perspective. So what my app.jar has, and I'm good with that. So coming back to Dockerizing the file, so what I need to do is I should just take this whole thing and create a Dockerfile. So the first and foremost requirement for Dockerization is you must have a Dockerfile. So the D capital and COERFILE, and there is no extension. And then next I should copy paste. I'll just explain what I'm doing over here. I'm telling that there's the Java 8 based project. So this all left side is the commands. This is that there's a dependency from the Java 8, and current working directory should be the root. So while inside the Docker environment, this should be the place where things should be started as a context. And then add the local jar, which is the host machine jar, inside the Docker jar, Docker path, sorry, which is this path. Copy this inside the Docker. That means while creating the image, take the physical application which is on the host file and put it into the Docker image, the copy of it here, into the context path, and then copy also some of the environment properties, which is application.properties, from the local to the Docker inside, which will be again following the same path because we have not changed anything in the relative path or something. So here, this is just a file name which will follow the same path. And then Docker runs on some port internally and exposes the different port, or it can be both same ports. So it has a running port and the exposed port. So running port will be one, which is going to be maintained and managed by the Docker engine, and exposed port is something we are explicitly asking to override it. So we can change both of them. So internal port and external port also can be modified by us, and it can be modified either here or it can be also dynamically updated while you are running the command of Docker run. And last one is the exact command that you want to run to start the application. So it is telling that there's a command which should be doing the java-jar file. So start the Java application from this jar file, and while doing it, please take this application.properties and pass it inside the Java jar file so that it can take the variables that it has. So far we have not created the application.properties, but we have a Dockerfile at least created. So let's see if our Dockerfile is correct. And yep, so this is something we needed to keep it inside the Dockerfile, and everything works so as per plan right now. But let's also bring the properties file. Is I'm just going to open my directory here, and just going to check if I have the properties file. I'm going to take it from the wood.inf classes. This is the unpacked version of the same application, and here I have the different properties that this application is looking for. So it has some of the Hibernate related parameters and some database which it uses. So this is the RDS endpoint, and this is the user ID and password of the same RDS MySQL database. So maybe I need to just cross verify and update it, but as of now I'm just going to copy and paste over here. So I'm going to say app.properties, the file name and extensions doing any typo or any problem with that. So once this is fine, then we can just verify again using the cat command, so that we can see, yep, everything looks fine. So let's verify the RDS moving forward towards Dockerization. Let's quickly do the RDS cross verification. So endpoint is fine. I'm going to have look database person DB or something. Yep, so myapp.jar instance. And this guy has the endpoint like this. Just to doubly sure, I'm going to copy and paste it again so that, or at least match it. So it starts with C3GAV. So it's C3GAVI and ends up with J3Q US EC2. This is the same one. There is no change. So I have already having my application.properties set with the right information. So these three of the informations are DB specific, which needed to change. The rest of the things can be unchanged, including the port number 5000, which I have already opened in a security group. So we are almost set from the perspective of networking and database side. Let's focus on the Dockerization of the application. So how can I Dockerize image of the application? So let's see what we have. We have three of the things. One, the jar. Second one is Dockerization file. So this is going to tell the Docker engine how this application has to be Dockerized. And then the dependency of the application jar or application variables and different properties file that we needed to set for application to work. So these three files are there in the app folder. And next we are just going to bring out the commands which is going to help us to build the application. So this is how you build your application. Now we are going to interact with the Docker engine. So we can run the Docker command just for testing and say Docker ps that if any container is running. So there is no running container. And now what we are going to do is we are going to build our image for the application myapp. So this is going to be quicker again. So that's not going to take much time because our application is very lightweight. It's not very heavy. So in a couple of more seconds, it should be all done by now, I guess. Yep. And now once it is done, you can read all the steps that we have mentioned in the Dockerfile. So first thing we said, get me the Java. That means this particular Docker image is going to be dependent on the Java. So from Java 8, start downloading it, which we can read here parallelly. So this is what we said in the Docker file. And start with the current directory. That was the second statement. So we said start switch the directory as the root directory. So start everything in the root directory. And thirdly, we said take from the local environment. That means from this local host file system to the Docker image inside. So this myapp.jar should be copied inside the Docker image. We'll see the Docker image in a couple of seconds, and put it into the same file name inside the Docker image, and copy the next thing, do the copy the application.properties. So there's the next step, to copy the application.properties to local inside Docker application.properties. Just next is to expose the port. That means once you are done with setting up all these informations, please also do expose the port 5000, and this is going to be external port where the client is going to interact with the application inside the Docker, right? So there's the next step, and final step is to run the command which is there. That means it's going to build the image, and finally this is the command which will execute to create the container. So you see this, there's the container which was launched, and later the container was deleted. So this was just for building an image and then creating a container out of it so that it can test, and then later it will shut down the container. That means it will remove the container so that once it is all successful, it can say that it's successful and remove it so that all cleanup can be done. But image will be still there. So we can see the Docker images command, and we'll be able to see two things. One is the dependency itself. So the application had the dependency on the Java, so there is an image of Java also created over here. This is nothing but it's pulled out from the DockerHub as a dependency. So DockerHub is a Docker registry, a public Docker registry, where this Java image is public Java image. It has pulled out because this application is depending on this. So my app is going to be the next image, which has the operating system inside, plus all the information which it needed to execute the program or application, like application.properties, myapp.jar, and all, etc. So that's the images listing, and we have two of the images. One image depends on another one. So my app depends on a Java, which we have made it over inside this step one. So in this step one, we can see that this is what we have mentioned at to bring the dependency image. Yep. So next is to say that Docker is -a and see that is -a Docker. So here we are giving a command to check if container is running. No containers are killed after the testing, so there's no container alive right now. What we need to do is to run a container. So we are just going to do the command docker run directly. We can say my app. Bringing up the application. So Docker is a nice way of scaling up the application as many times you want. So this EC2 instance can hold as many number of Docker containers inside. Only thing I would need is to hold the different port numbers, which I can guide my Docker engine to do that. So there are several Docker lifecycle managers like Kubernetes, Swarm, and several other tools comes in a market which are used to maintain the or manage the lifecycle of Docker, where it will also help in building the complete orchestration and managing the full ecosystem of the product. So this is where we have already deployed now, and the time to test the applications. What we are going to do is to bring out the IP address over here so of the application. So I'm going to quickly pull out that IP address from the EC2 instance. Port I'm going to use is a 5000, and there is a problem. Instead of colon is a semicolon. Happy. So let's start debugging what could have gone wrong. This is public IP, so there's no problem with that. Let's see the security group once again. If security group is fine. Yep, 5000 is open for both of the IP address addressing class. Let's head towards VPC. So anything now is only suspected to be problem in the VPC. So in my VPC, let me verify if I have public accessibility as per my different subnets. So I'm using the subnet myapp. Let me verify the route table of the subnet. So this is working fine. This is fine. There's no problem from here. And this as well is good. There's no problem from here as well. So what can go wrong? Let's open the security group for all for a moment just to debug and see if there is a problem with that. Here over here. So let's edit the security group inbound rule and make it for everyone, all traffic, and see that if that works. Instead of this, I'm going to call it as anywhere, and then I'm going to delete this one and save it just to see that if that's the only problem with the security group. Doesn't seem to be working yet, but our application is up and running for sure. So this is the application which is deployed and working fine. I can also check by to user at the our application is open on TCP port. Yep, so that's the expose port 5000, and the expose port 5000 is working fine. There's no problem from that list. So let's head back to the VPC once again, and let's verify the next stuff. So VPC, we have to see the VPC has the elastic IP and VPC is proper. This is my VPC, which I would like to just verify if it has the network ACL. Yes, route table, so same route table. This route table has the internet gateway, and that's fine. There's no problem with that. Where it is going wrong is fine, so all good. So this looks all fine. From this side, there's no problem. Subnet side, there is no problem at all. Network echo looks good. There's no problem. Allows all traffic. Yep. And route table works fine. There is no problem here as well. There is a route table association. So this is where my app is. So this is fine. Oh, maybe this is the problem. Okay. All right. So I got it. What is the problem? This is the problem. I'm using the IPv6 in my laptop. That's what it is being blocked by the Route 53. So should have go to route table. Route table for this one is ending with 3. Let's take this one. So 3FB, it's the same route table. So 3FB, we need to correct some entries. So we have to use one more rule over here, which will bring the colon 00 colon slash 0. No. This is there's something should be taken. Yep, I guess. Save root, and let's refresh the page. Okay. Are we having the application running? So I'm going to just stop it. Or stop the application. It will take a couple of seconds to stop the application. So once this is stopped, we'll give some container ID back as a acknowledgement. This is try with the same command, and we'll see this is exited. So now we should do the Docker use the same container ID to so now we should not see any Docker PSI. To use the external port as this. What I'm going to do is first going to tag it. So first, I'll tag my application. I'm going to say Docker. Here you will see the two images, and now after tagging, we are tagging because we want to put it into the repository. So once you are trying to put it into the repository, you should use your account name and then the application name convention is. So we should follow this convention and then tag it. Once tagged, maybe we can get rid of the older image that we have, which is We have two of them, and one is ready to go into the repository, which is my non-public image, but I'm going to push it as a public repository, so I do not have a private repository set. It's push this image. What I'm going to do is I'll just do the Docker login and to push the Docker image. I'm taking this and again, it's going to be quicker. Doesn't take more than 20 seconds. Yep, so this is done. Depends on our image size sometimes, so but ours is smaller, so this is taken very faster. And you have the image now into DockerHub, so we can go to the DockerHub and verify it. So we are here into the my account, and in the repository we should be able to see the image now. So this is the image that is newly updated a few seconds ago, and a description is missing. I could have this is the image which is latest one. So suppose if I just get rid of everything, rid of Docker images. So I'm going to this, and I'm going to say Docker RMI, which is remove image, and then I say remove of the dependency now. So this is something manually. The moment we do that, it's done. So we have deleted everything. There is no image, and we have already got rid of our images. So Docker images, it should say nothing. There's nothing running as a container. There's no image. So image and container both are cleaned out. There's nothing there, and we have the which we are going to use rm minus rf, and we do not have any source or any image or any container over here. So what we are going to do is we are going to do docker pull and our GitHub public repository where we have this. Also bring the dependency image along, so we do not have to do any additional homework for bringing the dependency images. It manages the dependency, so you will see how convenient it is. Once you build your Docker image, you can build as many container out of it in order to scale it and sustain the number of traffic or volume of the traffic that is incoming to the application server. And this is also helpful when you are building the microservices based architecture, where all of the microservices you can put it as a Docker components, and then use Docker Compose as a build, and then you can club a lot of Docker images of the different dependencies together and manage them as a single thread. And then if there has to be anything scaled up, you can make them as a group and scale together in the ratio of proportion of compute or processing that they do it. So that will help you to also make the system performant, right? So with the scalability. So as we have a Docker pulled out, then we'll check the Docker image, but when we run the Docker, would be able to build this, right, and run it. So this is running, right? So you see that the Java image is internally managed and pulled out along with the myapp, so it has that image inside. Was there while we are building the Java image went inside the myapp, and that is something there. This is how you run it. You don't want to keep continuing with this. This doesn't work over here in the CMD. So what I'm going to do is going to start one more CMD, not CMD headlets. So, and then I'm going to say SSH. So over here we see Docker is we see this application is up and running. So what we are going to do is, again, we are going to stop this to demonstrate one more of Docker RM. All of the active Docker images. Cannot remove running container. You have to use the host. This is a more devastating command, so use it very carefully, because I have only one container running, so I can use it, but this can result in terminating and removing all the container that is running over there. So it is just whatever active container is qualified with this, all the Docker container IDs will be passed to the while you are using this command. So next, what we are going to demonstrate or see, this particular application I start twice or thrice is going to create an software. So here I'm going to use internal port as a 5000 and external port as 80, and then launch it. This will launch with the 8080 port now, and switching back to the one that is terminated just now, I'm going to use the same. This time I am running on un. So two Docker containers are up and running. It's running, and this is how manually I'm handling it. But in real time, there is a AWS tool EKS, that is what you are supposed to use, which is Elastic Container Kubernetes system, which is handling the Kubernetes completely. Kubernetes is a platform to manage the Docker lifecycle. All right, so this is two of the applications up and running. Let's go to the browser and see our luck on the network side if we are able to use the TCP problem, right? So we didn't use the HTTP, browser didn't detect it. So that we can get rid of that as well while we're using the custom port. We should not prefix the HTTP. So that was the problem, but that problem is not a persisting problem anymore for us. So let's also check the application on 81. Now, if I have to scale further, I'm going to execute the same command third time with the new internally application is running on 5000 ports, but externally Docker is exposed on different ports, right? So this is the only task we have to do is to Dockerize the application, and rest of the things are so easy to manage. The same Docker image, the same application blueprint can be converted into the several instances of running container, and all those container, if it's a web-based, it requires some port so that client can access it. So that is something which Docker will manage for you, or you need a Docker managing tool like a Kubernetes or EKS, which is again wrapping up the Kubernetes internally. So such tools will help you to manage whatever the manual task we are doing over here. So it will cut down, everything will be automatic, right? So my DB should be connecting, so let's have a quick. Here from this application, and we'll see that I'm having the data entry done from here, and both of the application should, yep. So this is in sync, right? And if I refresh, this will become in a sync as well. So see, this is submitting the last information, which is duplicating this information. So this is what will happen if I submit here. This is submitting the it in fact says that confirm the resubmission, and this will bring the Aditya second time. So we'll have this information. I don't want to play the monkey cat game over here, so I'll just stop it here. But you guys understand that how this powerful can be the use of Docker into real time, right? So Docker is very powerful and effective tool to manage the real time applications very efficiently and very effectively. It doesn't take much time to build the Docker image. Doesn't take a lot of time to bring out the Docker container up from the image. So it is quick. It's very performant system. The Docker whole concept is very performant. So that's all from my side. I'll be signing off for today. Hope this was an enjoyable session for you, and if you have learned a bit of it and you think that I deserve a like, please feel free to give a like. If you have any question, I will be very happy to get back on the questions. So thanks a lot to learning along with me on the whole Docker process of the application deployment and managing it. Thanks a lot.